I am thrilled to be here with you to cover our 14th Cargo Resupply Services mission to the International Space Station. Today, for the second time ever, we are flying both a flight-proven first stage and a flight-proven Dragon. That means both the first stage and Dragon have gone to space before. And with T-minus 12 minutes and 30 seconds and counting, all systems are go at Cape Canaveral. As I mentioned previously, both our first stage and Dragon spacecraft have gone to space before. That Falcon 9 first stage, it looks a little bit sootier at the bottom there. That's because our refurbishment process does not involve us scrubbing that first stage to make it nice and clean. That first stage flew on August 17th, 2017 for our CRS 12 mission, whereas the Dragon spacecraft on top of the vehicle flew on April 8th, 2017 for our CRS 8 mission. Both Dragon and Falcon 9 were designed up front with reflight in mind, so the vehicle hardware is built to support multiple missions with minimal refurbishment in between. As I mentioned previously, the Dragon in the first stage looks sootier, whereas Dragon, as you see it on your screen, looks brand new. That's because we refurbished the thermal protection system, or TPS, on the exterior to give it that nice white, brand spanking new look as you see it now. For today's mission, SpaceX does not plan to recover the first stage. Instead, we're going to be pushing the limits a bit on our return trajectory so that our first stage can collect additional data that will help inform our future reusability efforts. We are going to be performing a landing sequence out in the Atlantic Ocean to gather that data, but there's no drone ship in position for recovery. That means that you may hear some countdown callouts on the countdown net regarding first stage entry, but for our webcast, we will just be focusing on our primary mission. That will be the second stage's journey into orbit and its eventual deployment of Dragon as it makes its journey to the International Space Station. But T-minus 10 minutes and counting right now. The good news is we continue to be on track for an on-time launch, tracking no issues at the moment. This is a Dragon mission, which means we are constrained with an instantaneous launch window. What that means is Dragon, Falcon 9 must lift off at this T0 mark. We don't have an open window with which to recycle the countdown and go again. It's instantaneous because we're trying to time our launch to the point where the International Space Station will be just about directly overhead Cape Canaveral, and then Falcon 9 and Dragon will be basically trying to catch up to the space station with eventual capture at 4 a.m. Pacific time on Wednesday. The most significant portion of today's countdown started at the T-minus 70-minute mark, where our launch control team was pulled at Cape Canaveral to enter into the propellant loading sequence. Now, as you may recall, in order to make fire, you need three elements: fuel, oxygen, and an ignition source. Our fuel for Falcon 9 is RP1, that's refined kerosene. And as we're sitting right now, both our first and second stages are nearly full of RP1. We will continue to top them off up until about the T-minus 5-minute mark on that first stage. We also carry densified liquid oxygen that's cryogenically cooled. That's actually those clouds coming off the rocket. That's the liquid oxygen boiling off. Right now on the pad, we're sitting at nearly full of liquid oxygen on our first stage, and about 95% full, 90% full on our second stage. We will continue to load liquid oxygen up until about the T-minus 3-minute mark. We also load on helium on board both stages. That's what we keep the tanks pressurized with as we're emptying it of propellant. Dragon, meanwhile, ready to go. It began its auto sequence at T-minus 35 minutes. That's where it begins its coordinated timing. It's moving into internal power, just transitioned that period right now. Everything looking good to go there. Range, also ready to go. Weather, looking pretty good. We were tracking some anvil clouds earlier, but it looks like any constraints that could affect today's launch will be actually after our T0 mark. Weather team is continuing to monitor these anvil clouds, but as of right now, no constraints for today's mission. So overall, we continue to be go from Space Launch Complex 40 at Cape Canaveral Air Force Station. "11 years ago, Dragon was just a design on a piece of paper. But in 2010, SpaceX became the first private company to send a spacecraft to orbit and return it to Earth. 2 years later, in 2012, soon after I started at SpaceX, a Dragon became the first privately developed spacecraft to visit the ISS. Since then, we've made a total of 13 trips to the space station, and we're under contract with NASA for a total of 20 cargo resupply missions. We are currently flying cargo to the space station, but ultimately, we will fly astronauts on crew missions, with our first crew demo mission slated for later this year. Our Dragon mission today is conducted in close coordination between NASA Mission Control at Johnson Space Center, also known as JSC. And on your screen, you're looking at a live view of Mission Control at JSC in Houston, Texas. The team at JSC there are monitoring today's launch, as well as coordinating the activities with our international partners of the space station. Dragon is packed with almost 5,800 pounds of research, crew supplies, and hardware headed to the ISS and its 6 crew members. Let's take a quick, closer look at what we have on board Dragon today.
SpaceX's 14th commercial resupply mission to the International Space Station will mark the first opportunity of 2018 to replenish this U.S. national laboratory in low Earth orbit with new and exciting research. Let's learn more about some of the featured investigations and facilities that are destined to station as part of this mission.
490 Biotech will examine anti-cancer therapeutics through a novel bioluminescent kit. This research could have far-reaching impacts on the drug development process, to include the timing of when therapeutics come to market. 2 student investigations as part of the Genes in Space flight competition will be evaluating various DNA experiments aboard the space station. Students from across the country have the ability to submit DNA amplification experiments through this program, which is sponsored by the Boeing Company. The Materials International Space Station Experiments Flight Facility, or MISSY, was developed by Alpha Space. This exciting facility will enable academic, commercial, and other government agencies the ability to put materials experiments on the outside of the space station, exposing these experiments to the extreme environment of space. The multi-use variable gravity platform developed by TechShot includes 2 internal carousels that simultaneously produce artificial gravity. This facility can be used to conduct research in space with a wide variety of sample types. A CUBE satellite mission developed in partnership with NanoRacks will focus efforts on the ability to remove debris in low Earth orbit. The mission will deploy 2 CubeSats as artificial debris targets to demonstrate technologies such as net capture, harpoon capture, and vision-based navigation.
This mission provides an assortment of research on Space Station that will benefit life on Earth, and will also bring new facilities to the International Space Station to further enhance our capabilities in low Earth orbit. And we wish our partners at NASA, SpaceX, and all of our principal investigators the best of luck for a great year of research in 2018.
Follow at ISS_research on Twitter for more information about the science happening on station. Along with bringing cargo to the ISS, an equally important function of Dragon is to return back experiments. Dragon is the only operational spacecraft capable of returning a significant amount of cargo to Earth. The good news is, Dragon has given us the thumbs up. Its vehicle is ready to go to space. And with just under 2 minutes and 40 seconds in today's mission, Falcon 9 has finished topping off its propellant loading. We've wiggled our engines, doing the thrust vector control checks on both our Merlin vacuum engines, as well as the 9 Merlin engines at the base, bringing us into T-minus 1 minute, where Falcon 9 will enter into startup. The rocket will take control of the countdown at the T-minus 1 minute mark. So we're gonna go silent over here on the webcast and let you listen in to these final 2 minutes of today's mission.
Stage 2, lock slow is closed out. Falcon 9 is on internal power. Vehicles in self-align. Gas closeouts.
AFTS is ready for launch.
Falcon 9 is in startup. Ground gas closes out.
Dragon is in startup.
Launch directors go for launch.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Falcon 9 is on its way to delivering the Dragon spacecraft for its 14th Commercial Resupply Services mission. Coming up in about 10 seconds, we have max Q, maximum aerodynamic pressure. That's one of the highest stress states on the vehicle.
Vehicle is supersonic. Vehicle is experiencing maximum dynamic pressure.
just passed through max Q. This first stage burn will last for about another minute and 10 seconds. As we leave Earth's atmosphere, you'll notice the exhaust plume gradually expanding.
And back engine chill.
And just heard the call out that the upper stage engine, the Merlin vacuum, has begun chilling in, similar to how we chill in the 9 Merlin engines before the initial liftoff of the Falcon 9. Now coming up in rapid succession, at about T plus 2 minutes and 40 seconds, we'll have MECO, or main engine cutoff, followed by stage separation, followed by ignition of the upper stage engine. Let's watch.
We have MECO.
Stage separation confirmed.
Back ignition.
And what you just saw there was a successful shutdown of the 9 Merlin engines of our first stage, followed by separation of our first stage from our second stage using 4 pneumatic actuators at the forward end of the stage. And then after that, you saw ignition of our upper stage engine. You may have noticed a piece of metal flying away from the engine. That's a stiffener ring that protects the larger Merlin vacuum nozzle on ascent. That's totally nominal. And on the left side of your screen there, that's actually the Dragon nose cone that it's popped off and is falling back to space. Dragon nose cone falling off, totally nominal. That's exactly what we want to see. We use that nose cone to protect the forward end of Dragon on ascent through the aerodynamic, the atmospheric drag we see. That's a good sign. That means we're outside of the atmosphere, so the forces on the forward end of the vehicle are significantly reduced. About 2 minutes into our second stage burn. If you're just joining us so far, the first stage had an on-time launch, just like we like it. A nominal ascent profile, good separation from our second stage. Now that first stage is performing an experimental landing maneuver. We're just gathering some data on this into the Atlantic Ocean. We do not have a drone ship out there in the Atlantic Ocean, so we are not covering this portion of the phase. Though you will probably hear some callouts in a few minutes on entry burn of the first stage. Since that's not our primary mission and we're not intending to recover that first stage, we will just be focusing on second stage right now. Coming into T plus 6 minutes, this second stage burn will last for about another 3 minutes. Our target, if you want to keep an eye, that speed, we're going to about 27,000 kilometers per hour. That's orbital velocity. Second stage's job is to get Dragon to orbit. first stage's job was primarily to get us out of the Earth's atmosphere. Second stage does its precise orbital maneuvering by using two thrust vector actuators. They're contained within that reflective blanket, and they allow us to adjust the engine's position, affecting its pitch and yaw. And then we have some nitrogen thrusters on the forward end that allow us to adjust the vehicle's roll. Power and trajectory continue to look good. Engine performance continues to be nominal, as we like around here.
Stage 1 AFTS has saved.
We are coming up shortly in about a minute here on SECO. That's a second stage engine cutoff. That's the point where the second stage in Dragon will be coasting. Dragon will then do a quick checkout, and then it will be deployed from the second stage about a minute after that point in time.
Stage 2 terminal guidance.
About 15 seconds left into stage 2's burn.
Stage 2 AFTS has saved.
And we have shutdown of the second stage engine.
Yes, you go.
You saw the speed tick up to about 27,000 kilometers per hour. We're going to coast here for about a minute, and then Dragon will separate.
Good, stage 2 orbit insertion.
And we just also got the confirmation that we are in a good parking orbit of our second stage.
Acquisition of signal Newfoundland.
Coming up on Dragon deployment in about 15 seconds. And that is a view from the forward end of our second stage, looking inside Dragon's trunk as it separates from the second stage. Those are 3 of the science experiments we're taking up to the International Space Station. You can see those 3 different boxes inside. Those are 3 of the experiments we're bringing that will be attached on the outside of the International Space Station once we berth. It's about T plus 10 minutes and 50 seconds into today's mission. On the right side of your screen, you see Dragon gently separating away from our second stage. We are coming up on our solar array deployment in about a minute and a half. That's where the fairings that protect the solar arrays will be released, and then our solar arrays will be slowly rolled out like a bit of an accordion, and then they will begin their pointing maneuvers. Right now, Dragon itself is checking out its thrusters. We are priming up the thrusters to make sure we have control over the vehicle first. We want to make sure we have control over the vehicle before we deploy those solar arrays. If you're just tuning in, second stage and first stage put Dragon into a nominal trajectory. We are in a good parking orbit right now. You are looking at the Dragon spacecraft with Earth in the background, looking through at the camera on our second stage, on the forward end of our second stage. Second stage itself will perform a third burn maneuver, which will put it inside the Indian Ocean for disposal. While we wait, right now we're waiting for Dragon to unfold its solar arrays. Dragon does need its solar arrays in order to conduct its full mission. It is a 2-day journey to the International Space Station. We have capture coming up Wednesday at 4 a.m. Pacific time. Those white clouds you're seeing in the space, that's just some venting that we naturally do as we are in space. And coming up now, though, we're still waiting for solar array deployment. If you're just tuning in, Dragon had a nominal mission thus far. It looks like we're hearing some cheering, waiting to see the confirmation. There they are. Those are the solar arrays unfolding from Dragon. That's actually the back side of the solar arrays. You can see the wire harnesses that connect the different cells together. What Dragon will do now is make sure these solar arrays are working, and then at T+3 hours, our GNC bay door will open. That's where we begin the precise pointing and navigation systems to get ourselves on our way to the space station, after which point in time, we will conduct a number of height altitude and orbital adjustment burns, eventually leading to that capture on Wednesday. And so to recap, we had a perfectly nominal mission, as we like around here. Falcon 9 performed its job splendidly, delivered Dragon to a perfect parking orbit. Dragon has since unfolded its solar arrays. You see that live view from space. That's certainly my favorite view from space of Dragon missions, of our solar arrays with Earth in the background. So because we're at this point in time, we're going to conclude our coverage for today's mission. We would like to thank NASA for today's mission, the Range, Cape Canaveral Air Force Station for their support, the FAA as well for their support, and most importantly, you, the viewer, for tuning in. If you would like to come and join us, please check out spacex.com/careers. Our mission doesn't end here. There are many more days to come leading up to the berthing with the International Space Station. Capture will be at 4 a.m. on Wednesday. You can check out all of that coverage on NASA TV. But if you'd like to follow along with us, be sure to follow our social media, Instagram or Twitter, as well as SpaceX.com. We will keep you updated on the mission's progress. Thank you for tuning in. We'll see you next time.